All right, so let's go ahead and go through and do a review. So the first one is rules. So go ahead and write the proper rule. What is a rule if you have the x root of y to the z? Now we've had this on both quizzes. You should be well versed in the rule, and hopefully you say this is y to the z over x, right? And that's rule number one. Rule number two, go ahead and do the second rule. A times the nth root of x times b times the nth root of y. Some of you guys take forever even to get the problem written down. You got to speed up. Okay, so hopefully you said to yourself, I have to multiply the coefficients and I have to multiply the radicands, right? I'll take questions over these when we finish all four rules. So, all right, third one, go ahead and complete that rule. Now you're adding a times the nth root of x plus b times the nth root of x. A times the nth root of x plus b times the nth root of x. So again, if you know what you're doing, you remember that you have to have a parentheses around the coefficients, and it's times the nth root of x. Now, here's the thing. You ever hear the thing, fool me once, shame on you, fool me twice, shame on me? Look, numbers of you didn't put the parentheses on your quiz. You got your quiz back and you got it wrong because you didn't have the parentheses. So did you forget the parentheses again? If you did, shame on you. Shame on you. Okay? Don't make the same mistake twice. All right. Last one here. Nth root of x divided by y. Nth root of x divided by y. The nth root of x divided by y. So hopefully you said the nth root of x divided by the nth root of y. Any questions on any of those four rules? Anything I can explain in further detail or help you to understand on any of those? Anybody? Kirsten?
For the addition one, is it okay if you put a plus or minus b?
The rule that I asked didn't have the plus minus, did it? Do you see any minus there? Okay. Again, the reason I used plus minus is I was showing you two rules at one time. Okay. Is this showing you both at one time? So you wouldn't have the minus then, right? Any other questions on any of those? Okay. Let's move next into changing form. All right, so go ahead and take number one and change it into exponent form. It's in radical form, change it into an exponent. It's the cube root of n squared. By the way, if you're having trouble seeing, we have seats up front. Why don't you move to the front if you're having trouble seeing? Cube root of n squared. That should be a quick answer. How many had n to the 2/3? N to the 2/3. Again, this is a straight application of the rule. This can be taught to a second grader, I'm telling you. Because it's just put this there, put that there. So it's just a memorization issue. Okay? Radicands exponent over the index. And that was a straightforward one. All right, try this one. Fifth root of 8x y to the fourth. Fifth root of 8x y to the fourth. Fifth root of 8x y to the fourth. This is not the best answer, but it's probably the answer a lot of you gave. 8 to the 1/5, x to the 1/5, y to the 4/5. And that's true. How many had that? Okay. The reason that's not best is the 8 is factorable into a 2 cubed. And it is better to say 2 to the 3/5, x to the 1/5, y to the 4/5. That's the better answer. Now, some teachers want you to factor any numbers. So you could have like a sets of numbers here because you factor all the way to prime numbers. I'm only concerned about factoring if that front number is all the same factor. A 2 squared, a 2 cubed, a 2 to the 4th, 2 to the 5th, 2 to the 6th, a 3 squared, a 3 cubed, a 3 to the 4th, 3 to the 5th, a 4 squared, well, it wouldn't be a 4, a 5 squared, a 5 cubed. Then I'm worried about the front number. If not, just leave it the number. And again, that would be a minor deduction. Minor deduction. Then there's no real standard there, so, but again, if the number's factorable, that's a better answer. Okay, now we're going the other way. Change that into a roots. 49 to the 1/2 power. 49 to the 1/2 power, change that to a roots. And hopefully you said it's what? Okay, change it to a root. So you're not going to say 7 because 7's not a root, though that is the value of it, right? You're going to change it to the square root of 49? Yes? Yes, square root of 49. Now, if we ask the answer would be 7, right? What's 100 to the 1/2 power? What's the value? 100 to the 1/2 power. What's the value of 100 to the 1/2 power? What's the, yeah, 10, thank you. What's the value of 144 to the 1/2 power? 12. What's the value of 64 to the 1/2 power? 8, right? What's the value of 125 to the 1/3 power? 5, right? Because that's a cube root. Okay, and again, this comes out of our understanding and knowledge of the forms. All right, so how about this one? Again, I want you to change this into a radical. Remember, we want a single radical. This is 3 to the 1/4 power n to the 5/12 power. 3 to the 1/4 power n to the 5/12 power. Convert that to a single radical. All right, hopefully those doing this at home are pausing each time. All right, so hopefully you said to yourself, I need a common denominator. I can make 12 that common denominator, therefore I'll multiply the first fraction by 3 over 3. Now I've got the common denominator, which is the index, and now I have 3 cubed n to the 5th. That's true. Is that the best answer? Because again, we should take care of numbers, and this is a 27. So the 12th root of 27 n to the 5th is the best answer. How many had either of those two forms? Okay. So again, going back and forth, common denominator. So look, this is how we started the chapter. We had questions like this on both quizzes. What's the probability of a questions like this on the test? High. Don't miss those. You know they're coming. You know they're coming. All right, simplifying is the next thing we went to, which is the key to the whole chapter. You must know how to simplify. It will affect you in every area of operation. It will affect you in multiplying. It will affect you in dividing. It will affect you in adding. It will affect you in solving radical equations. You have to know how to simplify. So simplify that. And again, you're going to pause because I'm pausing. So again, you say square root of 20. 20 is a 4 times 5. The square root of 4 is a 2. I can get a 2 out. Square root of x squared is an x. I can get an x out. Everything else remains in, which is a square root of 5. How many had that correct? Okay, good. And I was hoping an easy one to get you going. So how about this one? How about the cube root of 56 n to the 7th, q to the 14th. The cube root of 56, n to the 7th, q to the 14th. All right, so again, little things. Be neat, be clear. Cross out factors when you factor them. 56, 8 times 7. Again, I don't know how you went. You may have gone 2 times 28, however, 28. However you're going to get there, but you got to end up somewhere. I like 8 and 7 because the cube root of 8 is a 3, and I've already got a 3 out. 2. Duh. Be careful. See little mistakes. All right, no Kool-Aid for you guys. And then n to the 7th. Again, I don't know your thinking here. You can go n to the 6 times n and get an n squared out, or you can go n cubed, n. And again, you get one n out for that n cubed, another n out for that n cubed, so we got an n squared out. And then the q to the 14th. Again, I don't know how you're going. You might go q cubed. Wow, that's hard to say. Q cubed. Again, if you make the power divisible by the index, it's a shortcut. So I can go q to the 12th, q squared. What's 12 divided by 3? So q to the 4 is what I get out. Again, that's just a little shortcut, or you can do it the long way if you're better at that. What's left? Times the cube root of 7n q squared. How many got that correct? Okay, good. Most of you. Just be careful. That's about as hard as the simplifying is coming. It's about as hard as you'll get one. Eduardo, question, or are you good? Okay. All right. Then this one, probably most of you won't know what to do. But simplify that. The square root of 3x squared plus 12x plus 12. The square root of 3x squared plus 12x plus 12. All right, either you know what you're doing and you're there, or you don't. So, all right, what'd you do to the first one? Factored. What'd you do to the second one? Factored. What are you going to do to the third one? Factor. First law of factoring, factor out common factors first. Now let's see if I can factor the trinomial by trial and error. Of course, I know it's a special one, but you may not. The fronts have to multiply to the front. The backs have to multiply to the back, but remember, the outers plus the inners must equal the middle, and they do. What is the square root of x plus 2 times x plus 2? X plus 2. You got to leave that in a parentheses. What's left in? Square root of 3. Anybody get that one? Okay, good job. A couple of you. Again, as I said going in, most of you probably aren't going to get that. But is it anything different? No. Factor on 1, factor on 2, factor on 3. Look for 2 of the same factor. That's what we did. So we learned how to factor last chapter, and that's how you would do the problem. Any questions on any of those 3? You have to know how to simplify. Are you going to get 10 questions like number 3 on Monday? No. Did you get 1 maybe? Maybe. Okay. Are you going to get 10 or 15 or 20 questions that involve 1 and 2? Yes. Almost everything involves simplifying. You got to have simplifying down. No questions there? Okay, next. Let's go to multiplying. Don't forget the S-bum. All right. So you have the cube root of 2 times the cube root of 5 times the cube root of n squared. Go ahead and do that one. Cube root of 2 times the cube root of 5. Some of these you can just write the answer. You don't even need to write the original, right? What does it matter? Something like this, aren't you ready to just write the answer? Because what is the answer? Just say it. Right? Cube root of 10n squared, right? That's it. Multiply the radicands. Is there any simplifying? No. You got 1, 2, 1, 5, and 2 n's. I need 3 of anything. Right? So try this one. Square root of 10 times the square root of 6. Square root of 10 times the square root of 6. Okay, did you S-bum? Either that or you're a bum, all right? You got to be looking to simplify. 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 And if not, you're going to miss simple problems like this. Do not put the square root of 60. I need you to simplify. 2 and a 5, 2 and a 3. Do I have 2 of anything? Yeah, I have 2 2's. I can take the square root, and it's one of them, the 2. What's left? Square root of 15. 2 times square root of 15. How many got that correct? All right, don't forget the S-bum. Don't forget the S-bum. All right, how about this one? Cube root of 12xy squared times the cube root of 22 x squared y squared. Front one, cube root of 12 xy squared times the cube root of 22 x squared y squared. So again, it's all about S-bum. One, two, 3 2's, right? Because the index is a 3. All right, the cube root of 2 times 2 times 2 is 2. What about x's? There's one of them. Oh, there's 3 x's. I can get an x out. What about my y's? All right, I got 2 of them here. Let's split this one up. And now there's 3 of them. And I get a y out. And everything else stays in. Don't forget your index. Be careful, be neat. I see a 3 and 11 for 33, and I see a y. 2xy times the cube root of 33y. How many got that? All right, good, almost everybody. All right, multiplying, always looking to simplify. Any questions on any of those 3, anybody? Who went 3 for 3 in that section? You went 3 for 3 in that section. All right, good, most of you. All right, let's try the next one, dividing. So what do you do when you come up with a problem? Square root of 5/16. Go ahead and take care of that. Square root of 5/16. And I hope you're done. Hope you said the square root of 5. And this is, I wouldn't even be writing this, but you're thinking the square root of 5 divided by the square root of 16. And therefore, you're saying the square root of 5 over 4, right? And you're done, because we can take the square root of 16, and you're done. You're done. Now, what about a problem like this? What if we had 3 divided by the square root of 6? Somebody tell me in words what we need to do here. Can anybody tell me in words what we need to do? Ethan? Yeah, but give me the terminology. Terminology. Kaylin? We have to rationalize the denominator. All right? So go ahead and do that one. You got to rationalize the denominator. So hopefully you'll remember that you can't have a radical in the denominator. Otherwise, the radical police will issue a radical citation, which will radically alter your grade. All right, and so I need to be able to get rid of the radical. I have 1/6, which I'm thinking, by the way, is a 2 times 3. So it's a 6. And I need another 6. I can take the square root of 6 times 6. Whatever I do to the bottom, I do the same thing to the top. Where am I at now? The top is 3 times the square root of 6. You can't multiply that 3 and go inside. And the bottom, square root of 6 times square root of 6 is 6. And of course, I didn't leave it like that, right? I reduced the 3 and the 6 for the square root of 6 over 2. How many got that one right? Okay, rationalizing the denominator. Now, you guys have a little bit of trouble when it's other than a square root, but we'll get there in a minute. All right, let's try this one first. The square root of 10x divided by 3 times the square root of 2xy. the square root of 10x divided by 3 times the square root of 2xy. All right, let me get your attention. I just want to show you what I would be doing on this. If this were on my quiz or test paper, I would immediately draw the fraction bar. I would put the 3 on the bottom. I would elongate my radical sign, and then I'd put the 2xy in. And the reason I would do that is I would see that my 2 and 10 would reduce. By the way, this is gone now. And my x and x would reduce. Now I'll split it back up. What's the top? Square root of 5. What's the bottom? 3 times the square root of y. Now I'll rationalize the denominator. Multiply by square root of y on the bottom. Whatever I do to the bottom, do the same thing to the top. Final answer. Let me do it in red here. Square root of 5y divided by 3y. Right neater. Square root of 5y divided by 3y. Andrew.
Oh, can you do the top? Oh, why wouldn't it,
Why wouldn't what?
So why wouldn't it be 5y over 3y instead of the square root of 5y?
Okay, so let me clarify. So right here, Andrew, here's what I have. I have a 5x here, I have a y here, and I really have a 3 there like that, right? So now I took the rule, and I have to split this back up. So the 3 is in the bottom, the square root of the 5x is on the top, and the square root of y is on the bottom when I split that back up. Now I got to rationalize my square root of y. Oh, so did I leave? Oh, no, there's no x. There's no x. I'm thinking, what in the world's going on? Right? No x, that's just the square root of 5. So again, where do you end up? On the top, square root of 5y. On the bottom, the 3 from there, and the y from there. Square root of 5y over 3y. And again, if you need further explanation, I can show you here when we finish up. Okay, let me give you one more in this frame of mind. How about negative 2 divided by the cube root of 50n? Negative 2 divided by the cube root of 50n. Negative 2 divided by the cube root of 50n. All right, let's see if you're on the right track. You should be looking to rationalize the denominator. Do you see how a 50 has 2 5s in it? Do you see that? You should. If I'm going to be the most efficient, I'm going to factor this because of the 2 5s. Because now when I rationalize the denominator, remember I'm looking for how many of something? 3, because this is a cube root. Square root, you're looking for 2. Cube root, you're looking for 3. How many 2's do I have? 1. How many more 2's do I need? 2 more 2's. How many 5's do I have? 2. How many more do I need? 1. How many n's do I have? 1. How many more do I need? 2. All right, that rationalizes the denominator. Whatever I do to the bottom, do the same thing to the top. What do I have in the top? A negative 2 times the cube root. 2 squared is 4. 4 times 5 is 20. 20n squared. What do I have on the bottom? I get a 2 out for the 3 2's. I get a 5 out for the 3 5's. I get an n out for the 3 n's. I can reduce the 2's, and that's it. What do I have? Negative the cube root of 20 n squared over 5n. Now that's about as hard as that can get. Anybody get it? A couple of you? Well, you should, I mean, when I say that's about as hard as that could get, honestly though, there's nothing really difficult about it. You factor, You need 3. All right, don't pack up. We're not done. We got one more section left. All right, the last section is adding. Go ahead and do number 1. That should take you just a minute. 3 times the square root of 7 minus 8 times the square root of 7 minus the square root of 7. 3 times the square root of 7 minus 8 times the square root of 7 minus the square root of 7. And the answer is, should be negative 6 times the square root of 7. 3 of them minus 8 of them is a negative 5 of them. Negative 5 of them and a negative 1 of them is a negative 6 of them, right? How many got that one correct? All right, that's too easy of a problem to miss. Remember, adding, you got to have like radicals. Same index, same radicands, just like adding like terms. Second example. 2 times the square root of 3 plus 3 times the square root of 12. Go ahead and add those. 2 times the square root of 3 plus 3 times the square root of 12. All right, so this one, easy simplification. 12 is a 4 times 3. Square root of 4 is 2. Oh, now I have like radicals. Now I can indeed add them. 2 of them plus 6 of them is 8 of them. How many got that correct? Okay, good. Good. So remember, in adding, always be looking to simplify because you can get to the same stuff. Last problem, last one. 2 times the square root of 6 times the quantity. 3 times the square root of 3 minus 2 times the square root of 2. And then plus a 5 times the square root of 3 minus 7 times the square root of 2. 2 times the square root of 6 times the quantity. 3 times the square root of 3 minus 2 times the square root of 2. Plus 5 times the square root of 3 minus 7 times the square root of 2. All right, you can keep working if you want to, but for time's sake, I will show the answer. Now again, I'm going to take this simplistically. 2 times 3 is 6. And I'm going to leave the square root of 6 times 3 because I already see the common 3 there. The 2 3's that I can get out. Second distribution. 2 times negative 2 is negative 4. And again, I'm going to leave 6 times 2 because I see that simplifies. And I still have plus that and plus that. Let's further simplify. This is a 2 times 3. So I get a 3 out. So that's an 18. 6, 2 times 3. And this time I get a 2 out. Okay, so let me simplify here. 18 times the square root of 2 minus 8 times the square root of 3 plus what did I already have? 5 times the square root of 3 minus 7 times the square root of 2. 18 of the square root of 2's and a negative 7 of the square root of 2's is an 11 times the square root of 2's. Negative 8 of the square root of 3's and a positive 5 of the square root of 3's is a negative 3 square root of 3. Test on Monday. Hope you'll be ready. Have a great day.